welcome to our channel. In this session, we are going to discuss about secure socket layer, that is SSL. This SSL mainly used for web security, Simply, the SSL is used to provide security to the data that is transferred between web browser and web server. Simply, the data that is transferred between the client and server, the security is provided by using SSL. Okay. Now we will discuss in detail. SSL mainly consists of four protocols. The SSL consists of four protocols. The four protocols. The first one is SSL record protocol. Second one is Handshake protocol. Third one is Cipher Spec protocol. And the last one is alert protocol. These are the four different types of protocols available under SSL. So for your understanding only, I written 1, 2, 3, 4. Actually, how the protocols are stored? By using SSL protocol stack. I will show you the diagrammatic representation. The same protocols, they are represented as SSL protocol stack. So, first one, Handshake protocol, Cipher Spec protocol, alert protocol, and then HTTP, here SSL record protocol, TCP IP. So generally this SSL record protocol is above the top of the TCP and bottom of the below the HTTP. This is called SSL protocol stack. Now I will explain each and every protocol in detail. So what are the four protocols you need to write? SSL record protocol, Handshake protocol, Cipher Spec and alert. So coming to each and every protocol in detail. It's a very simple topic. The first one is SSL record protocol. So what happened inside this SSL record protocol? So an application data is given. So the first step is assume this is my application data. An application data is given. Generally the application data is divided in terms of blocks or also called as fragments. So this is my data. Divided into fragment 1, fragment 2, fragment 3 and so on. For example, for understanding, consider one fragment. Assume this is one fragment. Each and every fragment we are doing the same process. Okay. Once I received the fragment, what are the steps? Here first one is you are applying some compression algorithm on the fragment. Anyway, this compression is optional. If you want, you can apply the compression on the fragment. Now see this one. Suppose after applying the compression, so the fragment is compressed. Now what is the next step? Apply any secure hash algorithm, SHA algorithms or MD5 algorithms on this compressed fragment, which is used to generate the message authentication code. Now what is the next step? You need to calculate the message authentication code. Okay. Once the message authentication code is generated, again that code is appended to this compressed fragment. Now see this one. What is the next step? This is my compressed fragment. For this we are adding the message authentication code. Now you understand the point? This is my compressed, this is my, here anyway I will write down compressed plus message authentication code. Okay, after this what is the next step? Apply any encryption algorithm. That means you understand, secure socket layer provides the security to the data that is transferred between the client and server. That is, it achieves the confidentiality. What is mean by confidentiality? Unintented person is unable to see the data. That is, third party persons unable to watch the data. Here I send the data by using encryption. So here this is the procedure I am following. After completion of this one, apply any one of the encryption technique. Apply any one of the encryption technique. Now this is my compressed data. This is message authentication code. Apply the encryption on entire thing. So on entire thing in the sense, in this way apply the encryption. Now okay, the everything is completed, encryption is completed successfully. Generally in the layers, one layer information is transferred to the other layer. In that process you need to include the headers. Here also we are adding one header to the data. After completion we are adding one header to the data. So that is called SSL header. SSL header. This is added to the encrypted data. Now what the SSL header consists of and how that it is represented in the diagrammatic format? Remember, SSL header consists of mainly 4 parts. Whatever the SSL header we are added to the encrypted data, the SSL header mainly consists of 4 parts. The first one is content type. What is the content type? Here whatever the data that is generated, that is to be processed by higher layer. So to which layer the data is processed, the content type specifies the higher layer that will process the data. Now second one is, we have different versions of SSL. Different versions of SSL. What are the right now? The major version. So right now the major version is version number 3. After that the SSL header also consists of minor version. So the minor version is 0. So up to now these are fixed. The major version is 3, minor version is 0, along with it consists of length. So here length means that if you are performing compression, the length of the compressed data, the length of the compressed data, this one. Suppose if you are not doing any compression, the length of the plain text. That is, compression means length of the compressed data. If you are not doing compression means the length of the plain text. I already said that this compression is optional. Okay. This is the SSL header. Actually, this SSL header here only length, it consists of my compressed data or plain text. Yes or no? So understand the diagram. SSL header, it is attached to the compression, but it is attached to the MAC. Yes or no? Message authentication code. Now these two are encrypted. We are performing some encryption. I think now the diagram is clear. SSL header is added to encryption data. This is encryption. Under this encryption, the first part is compressed data or plain text. The second part is message authentication code. So this is the SSL record protocol. SSL record protocol. Okay. Now, even though it generates the output, remember one point. The SSL record protocol generates some output. This output is in pending state, not in current state. What is this one? I will explain after completion of second protocol. I think the first one is clear. Yes. Move to the second protocol, that is handshake protocol. The second one is handshake protocol. Handshake protocol, the main purpose is used to establish a session. Used to establish a session among the client and server. I think you know the meaning of session. So session means suppose you are performing some operation, you are performing suppose income tax department. Whenever you are open some income tax department, it opens a session of 10 minutes, or your ATM bank application, it opens a session of 5 to 10 minutes. So that means it establishes a session. Each and every operation need to be performed within that session. Suppose if you are idle for these 10 minutes, the session closed. If you are active, again the session re-established. Now, this handshake protocol is mainly used to establish the session between the client and server. Now, this protocol is completed in 4 phases. The handshake protocol is completed in 4 phases. I will explain each and every one. Assume it is the client. This is a client. And here server. Client and server. Follow step by step. The first phase is, among the 4 phases, the first phase is establish the connection. Even though the session is created, within the session you need to establish the connection. For that, what happened? Client send some message. Client hello. Client hello is the message sent by the client to the server. On receiving the message, server also sends the message server hello. Okay, by transforming these two messages, my first phase is completed. This is phase 1. The phase 1 is establish a connection. Yes or no? By transferring the client hello and server hello, we are establishing a connection. Okay. After completion of phase 1, now the server sends some information. What are the information? Server certificate. Server certificate. This is phase 1. So the server sends server certificate. The server also send server key exchange. Server key exchange. This is the second one. And the server also request the client certificate. Okay, server sends their own certificate. What is mean by certificate? You know thing. Anyway, by the end I will explain the concept of certificate. Server send their own certificate and server sends a key exchange and request for the client certificate, and finally server hello end. So by sending this statement, this is phase 2. The phase 2 is simply server authentication. Yes or no? The server sends all those information, that is called server authentication. Now here up to phase 1, phase 2, coming to phase 3. Exactly, once these things are received by the client, client authentication need to be done. Now what the client do? Same sense, client specifies client certificate is transferred to the server and client key exchange, whatever the information received from the server, exactly the same information, but it is related to client key exchange, and the request is not at all required. Why? Already I got the server certificate, I am sending the client. Now client hello verify, client hello verify is transferred. That means the third phase is simply client authentication. The third phase is client authentication. Now the server and client are authenticated each other. In between they transfer different messages. Once the authentication is completed, different messages. After completion of all the messages, you have to stop. Yes or no? For this, client send change Cipher Spec protocol. Client sends change Cipher Spec protocol, and the client send handshake completed. Handshake completed. That is from the client side, that is ended. Similarly, on receiving this one, server also do this one. What is this change Cipher Spec? I will explain. This is my third protocol. Yes or no? In the protocol stack, this is third protocol, and then server also send handshake completed. Handshake completed. This is the fourth phase. What is the fourth phase? The fourth phase is completion of handshake. Completion of handshake. So this is a handshake protocol. The main purpose is establish a session between the client and server. During the session, the first phase is it establish the connection by transferring the hello messages. Now you need to verify the authentication of the server by sending the server certificate along with key exchange, and it request for the client certificate. Similarly, you need to prove the client authentication. The client send their certificate along with key exchange. If once it is completed, change Cipher Spec protocol is called. Why you are calling this one? I will explain. After calling this one, the handshake is completed. Similarly, from the server side also, the handshake is completed. Now, among all these things, you need to know this important one. Change Cipher Spec protocol. I will explain this change Cipher Spec protocol right now. Change Cipher Spec in the sense specification protocol. Now, first SSL record protocol generates some output. Remember one point, until the completion of handshake protocol, until the completion of handshake protocol, the output generated by SSL record protocol is in pending state. Remember the point, again I am repeating. SSL record protocol generates some output, that is encrypted output. Yes or no? Now, until the completion of handshake protocol, the output generated by the SSL record protocol is in pending state. Once the handshake protocol. Once the handshake protocol completed, then the output in the pending state is copied into current state. The output in the pending state is copied into current state. You got it? Now, this conversion of pending state into current state is done by change cipher spec protocol. Now you understand? So, whatever the output generated by the SSL is in the pending state. Once the handshake is completed, you observe in the last point of handshake, I am using this change cipher spec protocol. Now, this protocol converts the pending into current state. So, this consists of 1 byte message. The change cipher spec protocol consists of a message of 1 byte long. By using this one, it converts the pending into current. Only one task. The purpose of this one is only this task. Okay. Now move to the last protocol, that is alert protocol. You know the meaning alert. Alert protocol simply to convey some messages between the client and server, or simple example, to convey the messages between sender and receiver. Sender and receiver, the alert protocol is used. Now the alert protocol is divided into two fields, each field of size 1 byte. Each field of size 1 byte. The first field is represented by the level. The second field is represented by the alert message. Two fields, level and alert. We have level is equal to 1. At the same time, level is equal to 2. Two values of the level. Level is equal to 1 means that is called warning. Level is equal to 2 means that is called fatal error. What is the difference? Warning. If you have warning means there is no impact on the connection between the sender and receiver. You know the warning messages. For warning, there is no impact between the sender and receiver. Fatal error means simply it breaks the connection between the sender and the receiver. It breaks the connection between the sender and receiver. It is not possible to resume. If you want, you can restart the connection freshly. If you want, you can restart the connection. So, based on this one, what are the different alert messages they provided? Here, every alert message related to certificates. Suppose the first one is bad certificate. Suppose if you are received some certificate, suppose the received certificate is corrupted or it is wrong, no certificate. Suppose I am not receiving any certificate. Suppose certificate expired. Whatever the certificate I received, assume the certificate is expired. Unknown certificate. Unknown certificate, that is during the processing of certificate it leads to any problems, that is the certificate is not related. Now unknown certificate, for example unsupported certificate. So the type of the certificate is not supported. The type of the certificate is not supported. Now certificate revoked. So whatever the certificate I received, that is under revocation list. That is under revocation. That is under revocation list. The next one is close notify. So close notify means the server does not want to send any messages. Observe, these are some warning messages. Even though you are getting anything related to certificate, it just leads to warning messages. But what is the fatal error? It breaks the entire connection. Main failure of handshake. Handshake failure. What is mean by this one? For example, if the sender receives some illegal parameters, Suppose the parameters that are not within the range, simply they close the handshake. They close the handshake. That is handshake failure. The connection is closed. Now decompression failure. Decompression failure. Suppose the decompression algorithm receives the wrong input. The decompression algorithm receives the wrong input. The connection is failed. Now illegal parameters. Illegal parameters. Suppose the parameters what we are received, those are inconsistent. The parameters are inconsistent and can be negotiable to any insecurity, though simply the handshake, simply the connection is closed. Next one is bad record MAC. So receiver is or sender receives the message authentication code. Suppose if the received message authentication code and the original one both are different, that means whatever the record we are received, that is the bad record. Finally, unexpected message. Suppose we are receiving a message not related to this connection, simply close this one. These are different types of warning messages and fatal errors. Finally, this is called secure socket layer. So, secure socket layer is simply used to provide security to the data that is transferred between the client and server. It consists of 4 protocols. SSL record protocol, which is used to generate some output. Based on that one, handshake protocol, which is used to establish session among the client and server. Change Cipher Spec protocol to convert the output generated in the SSL from the pending state into current state. Alert protocol simply convey the messages, that is alert messages between the sender and receiver. So among entire this, we are regularly used the term certificate. What is mean by SSL certificate? Simple for your understanding. SSL certificate is a digital certificate used to secure and verify the online transactions. Secure and verify the website. Secure and verify the data that is transferred to the online transaction. Each and every certificate is issued by the certificate authority. Before issuing the certificate by the certificate authority, it verifies the website. If everything is okay, then the certificate is issued. What are the characteristics? Because of that certificate, it provides the encryption. The certificate consists of encryption, integrity, authentication, non-repudiation, public key exchange. Everything is maintained during certificate. So you already know the concept, how to create a certificate. Example, X.509 certificate, like this only. This is secure socket layer. Thank you very much.